All right, so welcome everyone. You guys want to introduce yourselves? We'll start with Sean.
Good morning, everybody. It's great to see everybody. I'm Sean O'Mara, Field CTO for Mirantis. Looking forward to a great discussion this morning with Adam and the team.
Okay, Adam.
Hey, good morning, everyone. Adam Parco, CTO at Mirantis. I've already had 2 triple espressos, so today it's just water. I don't want to get too jittery on you guys.
You send one my way, Adam.
Definitely. And our special guest today, Alex Williams.
Hey, how's everyone doing? Hey, Alex here with the new stack. Oh, my mic. What's going on with my mic there? It's like not looking
It's magic.
Good. Yeah,
Your
it's like
mic is magic.
it's illusionary. Yeah, hi, I'm Alex of the new stack. I'm founder and publisher of the company, and we are happy to work with Mirantis as sponsors and love the kind of discussion you guys are having here already. So I was listening in and looking forward to getting started with our discussion.
All right. Well, this is great. We are thrilled to have everyone here. So today's discussion is about whether or not migrating legacy applications is actually worth it. We talk a lot about how to do it, and even why to do it, but it's the old you spent so much time thinking about whether or not you could, you never thought about whether you should. So that's what we're going to talk about today. So let's kind of start at the beginning here. How would you guys define a legacy application?
So, legacy is anything that, in our minds, that isn't necessarily running on top of containerized systems today. There are a number of legacy things that are probably already containerized, but using non-current container technologies, whatever that might be. But typically, we're seeing traditional client-server applications running on VMs or on bare metal systems that haven't yet adapted to or adopted CI/CD practices and containerization and orchestrators like Kubernetes or Swarm. That's typically what we're seeing, and it's a very loose definition. I get that, but that's how we're currently defining it, I suppose.
Would you guys agree with that?
Yeah, I'd agree with that. Other thing is, I think it depends on maybe the era you're in legacy application.
Your generation or junior engineers generation.
Yeah, I think anything today could be considered a legacy application that isn't like microservice based, right? That's kind of the the modern maybe like architecture you'd want for a modern application. But I also think the joke answer is basically any line of code you wrote yesterday, right? It's a legacy app, depending who you ask. So I think there's always going to be quote unquote legacy applications, and they're also probably some of the most critical applications in the world, and the whole entire world runs as a backbone runs on these applications. So it's kind of also derogatory to call them legacy applications. It's probably just applications.
Okay. Well, then what percentage of what's out there would you guys consider to be sort of legacy? I guess it depends on your definition, but the ones that we're talking about, whether it's worth modernizing them, and by modernizing, I think we're talking about that sort of moving them to the cloud native idiom. What percentage of these applications, what percentage of what's out there would you consider to be that?
What do you think, Alex?
I think probably the great majority of applications are considered legacy, and I don't have issues with the word legacy. When you think of like a hero's legacy, you're not thinking about that their past and how old fashioned they are. You're talking about their historical significance and and what status they have earned through all the work that they've done. And I think it's true in terms of thinking about legacy architectures. These have been the workhorses for for generations, and but everything changes, and there's no and today's great new modern technologies are tomorrow's legacy, right? As is kind of what I think we're saying here, Adam, right? And so the way I think about it is, I mean, if you look at, let's just look at compute, storage, and networking. Okay, I mean, if you look at the storage world, there's lots of talk about abstracting the storage architecture, and so you can create these interfaces to work, with a Kubernetes architecture, for instance. But what do the developers care about? What they care about is persistence, right? So they're not really as concerned about what's below the hood, so to speak. But there's a lot of people in the world who say, well, that's true, but that's still very important, all that that storage infrastructure underneath. So I think it just comes down to kind of matter, kind of who you're trying to suit. You trying to suit the developer, or you trying to suit the people who are kind of managing the architectures themselves.
It's an interesting perspective. I mean, if you look at it, we keep saying microservices are the modern application model. I read a book written by Microsoft Publishing in the 90s describing microservices architectures. That's the developer perspective. What is that? How are we looking at this through the narrow vision of infrastructure providers, or through the developer's perspective, or something in between?
Yeah, I mean, I like to think of it as something in between, where it's not so much how you implement it; it's what you're actually accomplishing. So what we're talking about accomplishing is applications that can run in that cloud native way. So applications that can survive if something goes down. Applications that and persistence is what we as developers, or most of us as developers, look for. So trying to reconcile that with this sort of cloud native stateless environment can be kind of daunting in a lot of ways. But more and more, one news item that we actually didn't get to is that more and more developers are adjusting to that in these stateless applications, these stateful, persistent applications are making their way into this chain. So why would we want to worry about it?
Well, I just think in terms it comes down to flexibility and really what you're trying to do. So, for instance, if you're building out a suite of you're building out new services, and you're trying to better reach, let's say you're an insurance company, and you're trying to that your customers want applications. They want to be able to get the information very easily so they can take care of whatever they're dealing with, be it a car accident or whatever, right? And it's been kind of proven that applications can really kind of speed up the process and can create some brand loyalty for you. If you can work with if I'm a customer and I'm working with a service that has a really easy to use application and gets me connected to the people who I need to be connected to, and gets the service started for my crashed 3-wheeler, whatever it is,
what do you do on your off time, Alex?
Yeah, on my moped caravan or whatever, I know I don't have a moped.
Yes, you do.
I'm thinking about an electric bike, but
Yeah.
But in any case, it's been proven, okay, so I'm the chief marketing officer, and I introduced 3 applications last year, and look at what it's doing for our brand visibility. It's really kind of made a big difference. Okay, I want to scale that now to 20 applications. I want to scale that to 40 applications. I want to be able to keep the current applications updated. I want to be able to do all these different things. Well, then, the dev team will be like, well, that's really fine and dandy, but we got a little bit of a scaling issue here, and that's when you got to start thinking about other things. You got to start thinking about, well, what services are we running? What's the platform that we have? What's the what are all these kind of issues that we hear about every day? And then the developer comes back and says, I'm having this real bad latency problem, and I can't really figure it out, but I'm trying this new tool and I really like it. Well, what new tool is that? And so it's that process of just learning and understanding, I think, that gets you to the place where you start to look at your own architectures and say, we need better services. We need better observability tools. We need better monitoring tools. We need ways to kind of manage these applications better. We got to hire 20 new developers and we got to onboard them. And, and I mean, it just goes on and on and on, in terms of how much software dependence we have.
Maybe that's a good qualification, right? Is your application currently being developed, right? Or are there performance issues with it? Or, like be looked at, things like that, like you said, monitoring, right? Those would all be good reasons why you might want to modernize. But maybe not all apps fit into that, right? Like one of my favorite examples is a friend once told me he worked in banking or finance or something, and he worked on an application that would screen scrape some type of back end teletype system to enter like commands to put trades through or to do some kind of crazy thing, right? It was going from like a digital world to like a physical world. It automated a human. And that was like, running again a backbone of our entire economy was through this like crazy application, right? Is that a candidate for modernization? Probably, but no one. It would have to be a complete rewrite.
I can remember doing that in the 2000s, setting up software on top of network desktops so that people could access mainframe backends through green screens that were screen scraped exactly the same way. Is that legacy application modernization? I mean, it's still running on the mainframe. We're just presenting it in a different way. What's the benefit to businesses of actually doing that ultimately?
Well, the benefit is, for instance, if the benefit of new architectures perhaps might be how quickly you can get the data, for example, like how, it's why streaming architectures are becoming, so important. We have so much data available that we need to think about how we use it effectively. And that's to me when like you start to see the difference, like, where I would expect, companies to start thinking, wait a second, can I really run all this streaming data through my mainframe? What are the interfaces that I need to set up? Is this even possible? No, it's not. Let's just keep on using the mainframe for the systems of record, right? Let's put a little bit, put it a little bit deeper into the data center. We still need it. But let's move that. Let's move some things forward that we think actually can solve some of these problems about the data deluge that we have.
And this is why COBOL programmers will always have jobs.
They'll always have jobs. Yeah.
Always have jobs.
So will PHP programmers.
And PHP programmers.
So will Java programmers.
That's
so will
right.
the fancy new Rust programmers. When 20 years from now they'll be like, Rust.
What's that?
Well, they were prophetic name.
Good name for what it does these days. Woo.
Another interesting maybe consideration, right? It's like you say COBOL programmers, right? There's a spectrum of modernization, right? Because even throwing some stuff into a VM, right, but bringing it into like a modern platform also has like tons of benefits, right? So you're kind of encapsulating maybe that legacy and that complexity, and adding additional tools on top that does the security, does the monitoring, learning, all those extra things. That's like another category on its own.
So it's a way to kind of slowly bring things into the present.
Yeah.
So I mean, well,
ultimately to move faster as well. I mean, if you think about it, you made the comment earlier in your news chat about open source, and we've spoken about that a lot recently. But by taking advantage of all these open source tools on these platforms that we can scale out, we're able to move a lot faster. Rather than creating things from scratch every time, companies can start to say, okay, I want my line of business application that's servicing my customers in in the financial services world or the insurance company, and I want to be able to add a mileage calculator in, rather than going to have to create all the backends for that from scratch. They can now just add that to an application within hours to days, and start to present that. And you couldn't do that necessarily on legacy systems, just purely because of the way we managed them. Never mind the agility to be able to scale out and provide resources in a test and go way. So,
Right.
and
so that kind of speed. So here's the question.
There's all kinds of trade-offs, though. I mean, here at the New Stack, we run on WordPress. I mean, WordPress is, a content management system that many people would consider legacy, right? Mm-hmm. And when I first started the New Stack, I looked at like static sites as a way to grow the New Stack, so I could have everything backed up on GitHub and repositories. Well, I quickly abandoned that when I looked at the editors for static sites. I was like, my gosh, I can just imagine, working with a PR person who's trying to like get some, get a technologist set up with I mean, it just, you'd start to ask questions like, well, what's your repository on GitHub? And the PR person would be like, are you kidding me? Or just any contributor be like, what, are you crazy? And so WordPress was just really the most fully featured CMS we could find. And that doesn't mean that WordPress is the be all end all, because according, to what you'll find out there is like, there's a lot of interest in these headless CMSs right now, a lot of interest. And they have really, really nice micro uses for developers, Gatsby, for instance, and just the capabilities that come with these new technologies. But it doesn't mean that, it only means that those have really great application use cases, for instance, documentation. For a new site, it's another matter.
Yeah.
That's I like that. That's a great example though, right? Because you didn't choose WordPress, at least at the time, for the technology, right? You chose it for convenience, chose it for speed, ease of use, right?
Yeah.
So the technology isn't always the end all, right?
So it's funny you bring up WordPress, because we were having a discussion yesterday afternoon about our site. And the challenges we're having are being able to flow things through the site and have the ability, to develop it as code, because we're a tech company. We like everything to be developed as code. But we're now running into a problem where we can't do tests of sites and pre-releases of sites with the way WordPress works today in a structured way, so that we can treat it through changes and git pulls and clones and things like that. So, and that's becoming legacy for us, and it's a problem we have to solve.
I will say that actually there is a way to do it, and we have done it in the past. And the fact that we are not still doing it should say exactly how well and how well that worked. But I mean, the thing is that what we're talking about here is sort of taking the path of least resistance. It's like WordPress is there, it's easy, it works, we're going to use it. Great.
But there's a difference though too. And that, also when we started, we focus on the real fundamentals, because I remember having this conversation and saying, oh my gosh, we're a publication that focuses on at scale development, deployment, and management. What if we went down? That would just look so bad.
Yeah.
I was like, I'm not going to let that happen. No way, no how. So that forced us to focus on the infrastructure, right? So we found a good cloud service provider that was right for our needs, that we knew that we could, basically keep things really locked down and secure. And, we hired a good system administrator and another developer who really worked well together, right? Because then we knew that they could, figure things out and help us keep, keep growing, so we could keep the latency down on the site. We had to look at kind of our image loads and so that forced us to move over to, Google Cloud's image caching service, right? So, we move over to the Google CDN, and for our images. And, these are the little things that we just had to do to just keep up. We had to focus on those fundamentals.
Yeah, but that's an interesting question. So you're focusing on these fundamentals, which is, as you're building out your site, you're focusing on the infrastructure. But if you had to start looking at moving from one of those providers you're using today,
right?
Think about what are your drivers to do that? What would be your core driver to make a change now?
Right. We've looked at that too. And we said, no way, no how. We're not doing that. I mean, that would just upend us for a long time. And, it may make sense if the new stack decided to build out a new site, right? Maybe we would host it, on the same service provider, or we would go to someone else. I don't know. We'd have to look at that decision and make, and make the call. I think I think we're no different than any other business out there who's looking at these different options and opportunities and what they can do, what they can't do.
Right. Yeah, you need the right business drivers, right? So if there's some cool new framework, it's like, okay, the tech is cool, but it's not a reason to switch, right?
Yeah.
And which actually, I mean, I just want to kind of point this out for a minute. WordPress is open source. Most of the tools you're using are open source.
Right.
But you're still locked into a particular provider.
Right.
And a particular way of work, more importantly.
Right.
Yeah. Just using open source does not mean that you're not going to be locked in. You have to make those architectural decisions carefully.
Right.
It does raise an interesting question though when you start talking about it. We recently did an engagement with a large US bank where we were talking about their legacy and what they're trying to do, and they have very little in the way of modernized systems.
Mm-hmm.
And we were talking to them about what their drivers were, and for them, the driver isn't necessarily modernization for the sake of modernization. It's that the legacy systems are getting too expensive to maintain.
Yeah.
So the cost of keeping things alive, despite that those technologies are not that old, it's that the companies that used to support those systems have either made them end of life or deprecated them, or frankly don't exist anymore. I mean, that's the nature of our industry. And they're looking at this view of they've got things that work and they are stable and they have been stable for years, but the cost of maintenance is so astronomical that it's actually worth it for them to migrate and even refactor in many cases those applications.
Yeah, that's really critical.
You think cost is the biggest reason? Like the other one I think is just speed. Right? So why containers took off was you could go from a 6-month or 12-month release cycle,
right,
literally down to minutes or hours.
Right.
That changed the whole industry.
Yeah, that's it right there. Yeah.
But for some companies, I don't think that matters. I don't think all companies want to be releasing, every day or several times a day.
I don't know why you wouldn't. Like, give me an example of who wouldn't want a continuous delivery.
You know what? I think that if you are a company, well, first of all, I mean, if you're a smaller company that doesn't have the ability to produce code that fast, that's one thing. Another thing is if you are in a situation where things need to be done very carefully and very deliberately, I'm not saying that you can't still be benefit from a container architecture. I think almost everything can benefit from a container architecture. But I mean, well, that brings up the question. Do we need to migrate from VMs to containers, or can we just leave things, say, in VMs? They're there, like Sean says, they're there and they work.
Yeah. So it's kind of my point of not baby steps, but partial migrations. Like even micro VMs, right? And then orchestrating VMs alongside your containers. That's an interesting approach as well for at least beginning that modernization step and having more visibility and control over how your workloads are run and how they perform.
Sure. Or running your VMs as containers as well.
Yeah, I think so. What Ed was getting at there as well. I mean, it is interesting for me. I look at it this way. I don't believe that every application out there is suited to go into containers. Yes, we're getting more and more so-called stateful applications ending up inside containers. I don't think that's a good thing. But there are a lot of applications that could just benefit from taking advantage of new infrastructures, leave them in VMs. Yes, there's a management overhead, but it's kind of tried and proven. And if you don't need to go and rewrite those applications to push them into containers and they still work, and there's not going to be a huge amount of cost benefit to making the change. And that cost benefit is not just about the infrastructure, it's about the people who are supporting that infrastructure, which I think is a critical point. Then why push the change?
Yeah, which brings us back to the whole question: is it worth it to do this?
Well, we cover this kind of story all the time, and it does in many instances come back to speed. Being careful and deliberate is always important. Some people, want to just use their existing infrastructure to do that. Others are saying, well, we want to speed up this process, right? We want to speed up this workload.
But I'd say speed also allows you to be careful and deliberate as well. It's like the longer your code sits there, the harder it is to integrate and test.
To look at it, be able to see it and observe it. Yeah. And I just, I think of, for instance, the cloud service providers, like AWS, at the bottom of their container stack is actually a micro VM, right? I mean, it's containers all the way down until you get to that kind of real instance where the hardware really has to work effectively, with the software that's running it. So if you're gonna, Sean, we talked about this the other day. The data center is changing dramatically.
Yep.
There's big old buildings that will be there for a long time, filled with infrastructure. But there's also increasing numbers of points across the network that are programmable, right? You have to think about, what is my backup for that? If I'm really trying to get the most out of my machinery, if I'm still in the in the industrial business, if I'm in a company that provides kind of a works in the petroleum industry or works in in manufacturing, you're looking at your own architecture there, and you're looking at how updated it is, right? And how well it performs. And there's now new ways to be able to monitor that. You can see if the equipment's wearing down. You can see if there's a load point that you need to be able to, manage. And maybe there's, and all of that kind of technology is programmable, right? So if you have I use the example of we're a climate data company that has thousands of nodes 10 miles off the coastline from Mexico to Canada, right?
Yep.
And those are all collecting data. Each one of those are nodes, and each one of them is programmable. And now you got to think about the compute, storage, and networking that goes with that, and then all the other matters that you're trying to figure out. How do you bring the data in? How do you do all these things? So I think it's increasingly interconnected, and if anything, that's really the story. It's an interconnected world, and it's how do you prosper in an interconnected world?
Absolutely. And I'd like to get back to the programming, to the programmable issue and all of that, but we do have a question, and I'd like to kind of jump in there. How can we address the security and compliance issues when we're moving from legacy to cloud? And I'm not going to try and pronounce your name, and I apologize because I will butcher it, and it's worse for me. It's better for me to just point at the screen, I think. So what do you guys think? How can we address these security and compliance issues in this move?
So I think one of the core things which we have to take into account with all these changes is the culture of the organizations that are dealing with this. And I'm going to give a bit of a broad answer before I cut into this, but ultimately, security and compliance is a mixture of technology and people, and it's how we apply that. And the change to being able to take advantage of these technologies, these programmable nodes, being able to distribute applications and systems very widely across, in the past we had big data centers had 7 layers of security, very, very, everything from blast fences or, truck-proof fences through to airlocked, bomb doors in our data centers. We don't have that necessarily anymore. I mean, to Alex's point, a node can be an IoT device hanging off a telephone pole or on a buoy in the middle of the ocean. So for me, I think addressing security and compliance is a combination of teaching and changing the culture of the way we develop applications, the way we push those applications, so that everybody has a test and validate and approve process. And then using modernized tools, proper code checking or anything, automated code checking before anything goes into production, multiple layers of security. We can't think of security anymore as perimeter security. We've got to put our security inside our applications, and in fact, start to ignore the perimeter in some ways, because if we're relying on a perimeter, well, we're stuffed. I mean, we could go on about this, but it's interesting to hear what other people in the industry are doing here.
Yeah. So what are you guys hearing about what's happening in the industry in terms of this kind of transition?
It's the hot topic. It's the number one topic right now. It was talked a lot about at KubeCon. There's more security startups than I've ever seen before. The software supply chain is really the big question mark that people have, especially as the perimeter has, one thing that has been effective is the perimeter is now difficult enough to penetrate that the attackers are going to where it's easier to get inside, to do their attacks. And it's really raising questions, I think, about third-party software, right? And how well it's, architected, And so I think this is a wake-up call to a lot of vendors out there, software vendors out there, who for a long time have just tried to just kind of like, it's a financial issue more than anything. It's like, we really gotta serve our customer base, and we gotta that's what we developed 5 or 10 years ago, and we can't lose them, right? We can't give up on them. And so what happens is then, you have these I think monolithic architecture is a different term than legacy architecture, in my view, at least. And the monolithic architecture, try to update that code base in any way. Try to how do you do that? How do you version control a monolithic architectural environment? It's really hard to do.
As my father would say, with much difficulty.
Oh, difficulty for sure. Difficulty is the number one issue. No, but so for example, there's a story in Wired that I read a few days ago about a hacker who found a third-party software that was really not well managed. He was able to then go around and search around universities to find who was using that. He then was able to penetrate into these university systems to be able to then get access to more. He was able to then actually get into one of Europe's largest telcos, and only because he wasn't very smart about protecting his VPN did he get caught. He finally got caught, but this is not a new story, and I think a lot of the brunt of of this goes on. First of all, one thing the pandemic has taught us is that we've all gotten pretty lazy. Every one of us have gotten pretty dang lazy, especially in first world countries like the United States. The people have just kind of like, well, whatever, it's my job. I'm not going to pay attention to that. I think you see it in all kinds of industries, and you see it in law enforcement. You see it all over the place. Well, that's what I do. Just leave me alone.
We're all tired.
We're all tired. Come on. And what happens is that makes you extremely vulnerable. Extremely vulnerable.
True.
You can't let down your guard, basically.
Yeah, and so and once you realize that you've let down your guard, now you've got like 2.5x the work to do.
Yeah.
And that's where we are. It's like you've got to realize that we have 2.5x the work to do.
That is very true. We have another question, which is basically, SolarWinds is on everybody's mind. Will it drop off the radar next year? And before I kind of throw that to you guys, I want to point out the more things change, the more they stay the same type of thing. You were just telling the story about, someone who, went in through university and found a vulnerability and made their way into a major telco provider. I assume that this was recently.
Yeah.
And I say assume that this was recently because I assume that it is not the situation where I actually had a friend who did that back when we were in high school in the 1980s.
Yeah.
Well,
and wound up taking down a large portion of a phone network.
Well, see, that's a brilliant example, and I'm going to answer Alex's question here. I answer this question here. Unfortunately, as soon as it's no longer fresh media, it'll start to slide out of our consciousness. I think one of the big challenges, the SolarWinds hack example, is a great story about similar hacks happening in the Ukraine, which was a jumping off point to taking down the power networks in Ukraine. That was 7 years ago, 6 years ago now. And there have been many published similar hacks over the years. And for a while, we all jump up, go, damn it, we have to do something about this. And then, that 2.5 times workload gets in the way and we start to think about other things and trying to move faster. We need to start changing the culture, and we need to start doing things differently and looking at security as core to what we do, especially if we're looking at migrating of applications and changing applications.
I would argue the culture is changing. And it's a question of how fast it will change. And, and before you know it, it will have transformed. I think we're starting to see that now. For instance, with the real advancements that started in 2012 with AI and what we saw coming out of Toronto from the technologists there, and it kind of was spread around the world. The ability to remember things is not necessarily something the human mind is capable of doing, but there's new kind of ways for you to be able to find the patterns that can help you make decisions so you don't let things just slide. And I think kind of that's kind of, that to me is like, to me that supports my argument that people have just, kind of just become complacent. And you can say they become complacent because they're relying on technology too much, or you could also say they're complacent because they're not relying on it enough, and they're resistant to change. Humans have a difficult time with transition. You see it all the time. I got divorced. The transition was hell, right? From going from being divorced to not, to that transition. Any transition is difficult.
Mm-hmm.
And that's the hardest part, I think. And I think that's the hardest part that we're seeing right now in a lot of different software communities.
The other thing I want to add is not everyone, no single person knows the entire stack anymore of their applications, right? From C libraries deep in the kernel, right, to the kernel, to the OS, to application frameworks, say Kubernetes orchestrators, to third-party software add-ons. like the end-to-end stack is just massive. And it's really hard to kind of wrap that in an onion everywhere to make sure it's secure. And then you're also relying on many people, also lots in the open source world to make sure your stuff is safe. So like I think what you were saying is we're going to have to rely, and I think this kind of speaks to it, is that we're going to have to rely on technology and things like AI and just automation to be able to analyze and interpret and inspect, because there's almost going to be no other way to secure it end to end when we have so many things out of our control.
But isn't that a good argument for us to abstract more of that complexity to trusted organizations?
Yeah, absolutely. That goes back to the open source thing, right? No one builds entirely purely on open source because it's just too daunting, right? You need partners to package that up, to secure it, to sign it, scan it, right? Authorize it, distribute it, like everything else that makes open source kind of palatable in at least in a mass scale enterprise organization.
Yeah, I mean, I think that what we've come to is a world that is, as you say, too complex for anybody to handle everything at the same time. And Alex, to your point of the fact that we now have the ability for AI to come in and recognize security threats and so on. I mean, my sort of holy grail of a system is something that is the whole AI ops situation where you have systems that monitor themselves and they know what's going on and they kind of augment the human. I don't think anybody's going to. I don't think we should replace the human element, but to kind of augment all of that, I think is important. And it comes down to, Alex, what you were saying. Are we using the technology enough to kind of get us over that 2.5x hump so that we can do the things that we really have to do?
But is the question enough, or is the question in the right way?
That is a good question. What do you think, Sean?
Well, I kind of would like to hear Alex's thoughts on it, but I mean, for me, I think technology always has its place. We go back to tools, but it's also about using the right tools. If I use a 10-pound hammer to knock a tack in, I'm going to break the thing underneath it. And I'm also creating a whole lot of complexity for myself. Whereas if I use the right tool for the right job, and I can trust that that tool is going to do the job for me, and it abstracts that complexity away, it means me as the so-called thinking machine, which is what a human is. We're supposedly are more creative than the machines, the AI. As smart as AI is, we're the ones that can have leaps of imagination. So, how do we fit as a cog? The developer fit as a cog into this larger machine, and ultimately, that's about having the ideas and being creative. Which means those tools we're using have to be appropriate for the job. And if they're too complex for us to use, then we're not going to use them. I know it's a circular argument. But...
No. I think you're right. Alex, what do you think?
One of the great learnings I've had over the years is just the wonder of the maker, the people who make things, the people who create things. And those people come from all walks of life.
Mm-hmm.
They're developers, they're engineers, they're writers, they're videographers, they're audio experts. They come from every walk of life. And those makers are the people who are always trying something new. They're always experimenting. They're always just seeing how something will work. They tinker. And that to me is such a fever once you get it. You can't lose it once you get it. And I believe that those people who tinker, those people who make things have been around for thousands of years. They're what has helped us propel the humanity forward. And that to me is the difference in how I think about AI versus, not, for instance. Humanity is we're very curious. We're very curious as a species, and we're always trying new things. Sometimes your mind might think a little bit differently than mine, and your mind might think it differently than that other person who is like figuring out how to get a backdoor into the bank. So humanity comes with all kinds of ups and downs, and in different ways. And to me, I just have to kind of like just put my faith in that. The people who are, whether you do it the right way or the wrong way, or too much one way or too much the other way. That's just the way people work. And I think that's where it really becomes down to like really great managers, really great managers who know the balance there, who understand that, and like really take confidence and faith in the people who they work with, because they've hired them. They better be, if you hire the people around you and you're not happy with them, you haven't done your job, right? Like, what did Steve Jobs say? He said, I hire someone not for me to tell them what to do. I hire them for them to tell me what to do. And that to me is just I think both the rejoice I have in like free open source software. I know you don't like the term free, Sean, but I think but in terms of open source software, I better be careful what I say.
I'm gonna have to get on my soapbox again there.
I know.
Yeah.
But if you look at open source software, and just the community of the commons, right? It's both wonderful, but it's also fragile too.
Yes.
And when we mess with the fragility of really, of long-standing systems, that's when you will start to have a breakdown. It's okay to critique it and understand it, but when you start to like try to like subversively get underneath it and change it, that's when the problems happen. But that's humanity too. And so I just love good managers. I think good managers really are the ones who can help us kind of channel that creativity and that energy to find ways that will work for the organization whatever one you're talking about.
I think it's an incredibly important point. It's the collaborative nature of what we're doing with open source, the collaborative nature with this new way of work. And one thing humans, despite some of the media noise to the contrary, we're actually bloody good at collaborating.
Yeah, we are.
Across boundaries, many boundaries. And ultimately, taking advantage of new systems means we have to collaborate. We may be doing it explicitly with people or implicitly with APIs, but that's a form of collaboration in its own right. And that's what, to me, open source is. It's about that community of collaboration. I think that's a very powerful idea when we start talking about moving from this old monolithic world to a more distributed world.
Okay. So two things before we kind of move on. One, if you're in the audience and you have any questions, please feel free to drop them in the comments. We're scheduled for another 9 minutes. Do you guys need to leave exactly at the top of the hour, or are you cool with us running over a few minutes?
I'm cool with us running over a few minutes, but I may need to take a bio break pretty soon. So
okay. Alex will disappear and come back. So here's a flammable question, I guess. We talk about legacy applications. Will Kubernetes be legacy someday?
I think, of course.
Everybody's nodding. Yeah, I mean, I don't think that there's any way to kind of avoid that. So Alex is going to be right back. We know what he's doing.
He's trying to get away from having to answer that question.
He's trying to get away from it. That's right. Well, we can hold it for him and surprise him when he comes back. Like, oh yeah, we just sat here waiting for you, Alex. I mean, what do you guys think?
Yeah, I was saying, like, of course it will. I think, like, even in our definition earlier, people who are writing code today for Kubernetes is a lot. There's probably already a lot of legacy applications running on Kube, right? But maybe the question more is like, will Kube itself, right, be like, oh, remember that decade Kube was all the rage, and we got this running some kind of new VM or container or something where we threw it in the corner that's still powering our entire infrastructure. Probably. I don't know what that looks like. If I don't have a crystal ball, but I could imagine there's going to be some natural progression as the world evolves and needs change.
Yeah, I mean, I think that's like you say, I think it's inevitable. But I mean, two things to say about that. I mean, first of all, I remember getting a message that said, you have to try out this new World Wide Web thing. It's even more popular than Gopher. So, I mean, that shows how old I am. But at the same time, while Kubernetes may become legacy, do you think that so we're still on the question of whether or not Kubernetes will be legacy at some point, Alex?
Mm-hmm.
But even if I mean, we've decided that it's inevitable that it will become legacy at some point, but we still have mainframes, so it's still going to be around, no?
Yeah, it'll be around. We'll have to be around. If we change course, it'll take a long time to change course. I think it's going to really require just a lot of work on finding ways to get Kubernetes up and running, so improving the developer experience. There's still a lot of work to do there. And there's going to be still a lot of work to be done to, to make it something that you can scale internally at an organization. And so if you can't scale it internally at an organization, I'm afraid it'll always kind of be on the side of the chasm that it is now. And to cross the chasm, it'll require a lot more understanding of how to build scalable architectures. And so I wonder, and this is where I wonder, like, as training and inference models become more commonplace, will that be a catalyst for Kubernetes, or will that be something else? And that's kind of what I'm wondering myself right now. I think GitHub Copilot's an example of something that maybe came a little bit too early. It wasn't quite ready for prime time, but I think those types of systems are coming where basically you can your IDE can be set up, while you go out for lunch, and you come back and it's all there, those are the kind of things I think that are coming. And, then Kubernetes might be the perfect underlying architecture for that.
Yeah. Because along that same lines, I'm thinking like Linux, like how old is Linux, right? Is that considered a legacy application?
I would think so. I mean, but but even Linus Torvalds recognizes that, right? At the Open Source Summit, he talked about the programmers who are building out the kernel. There's very few people who know C, right? And and so that's why he is saying, like, the drivers should be programmed in Rust, right? It's just going to be needed. You're going to have to do that because you don't have the people to to build these things. They've worked for 30, 40 years building kind of the underlying infrastructure, and we need to start to find ways to to get new people in who may know different programming languages besides C.
Right, because the original programmers are starting to retire.
Yeah,
but
yeah.
I think it's more than that. I mean, ultimately, Kubernetes, Linux, all these systems are infrastructure.
Yes,
they're a supporting platform on which we build applications, and those applications. I mean, Kubernetes is not an application that is providing a business value to an organization directly. It's a supporting tool, as is Linux. We could argue the same about Windows. Windows and Linux, they're just operating systems. I know I'm probably going down a very dangerous path here, but ultimately, they are a supporting layer that allows us to run applications that provide value to the businesses.
Right.
And
I don't really agree with that. I think it's a very specialized application, right? Of course, you use it in infrastructure context, but like it's an app, right? Like you can even go down to like a device driver, right? Like with SmartNICs that are doing really interesting applications. Like it's an app, right? It's not just a piece of.
But is it an app that's ultimately providing value to the organizations that are consuming it?
Yeah, indirectly.
So when you go to, we'll use the insurance company example again. When you go to your insurance company to go register a claim, do you care? And is there any direct monetary value to you if it's Kubernetes, VMs, or a monolithic mainframe application underneath that, as long as it works?
Oh, just as much as you don't care about the car you're driving, or really what's and kind of the dynamics of how the pistons fire.
Exactly.
Yeah. Okay, so we are.
What? I know you do.
I do. Right?
I know you love it.
This car, I want it to sound cool.
Yeah.
I want it to be reliable.
Yeah.
You pay money for that. I think it is.
Yes, but you're paying money for it to be reliable. You're not going in there with a spanner yourself, are you?
I'd like to.
Yeah, good luck with a modern car, but
you are a weirdo.
Thank you.
I like you, Adam. I like you. I like that. I think you're right. Like I'm like, like our we have a new dishwasher and it starts making all these funny sounds. I'd like to know why it's making those funny sounds, right? Yeah. I'm not very happy about the new dishwasher making funny sounds.
But to be fair, we are of a generation that could get into our systems as we were growing up and probably help own soldering irons. You'll find the vast majority of kids today are just totally disinterested in that. I mean, my son is certainly completely disinterested in how things work. He just wants them to work.
That's true. That's true. And I think we need to keep that in mind as we go forward. So here we are at the end of our session. It has been fun. So let's kind of wrap up and answer the question. So moving legacy applications to cloud native, is it worth it in the view of everything that we have discussed? Alex, yes or no?
Gosh, I would like to talk with Adam about SmartNICs. I'll have to save that for a conversation with you another time. I mean, heck, SmartNICs are so cool. Like the ability to like run service mesh on either the networking layer or the programming layer. I think that's fascinating stuff. It gets into the heart of the API and kind of what it is. Cloud native is here to stay, and the innovation is there. The people who are building the stuff are the most curious people you'll find. They're explorers. They're doing stuff that really matters, and people are really finding it a value. It's here to stay.
I agree. Adam?
I think Alex said it great. My answer is going to be it depends, but I think there's always going to be a way to do partial migration to bring it to cloud native in some fashion. So maybe the answer is always just yes to some level.
Sean?
I'm afraid I have to agree with Edmund. Ultimately, it's going to be yes. I mean, it makes sense. We're always going to be moving forward. What I will say is whether that is going to be to Kubernetes as cloud native or some future technology, because as we started the conversation, the vast majority of workloads are legacy, and what we wrote today is going to be legacy tomorrow. So we're always going to be moving forward, and we're always going to want to move forward. I totally would love to sit on that conversation when we talk about SmartNICs, because that's a big part of what we're talking about here.
Well, then we're just going to have to put that into the schedule, aren't we?
Mm-hmm. Sounds like we've got a new topic for another week.
There you go. All right. Well, that is great. So, all right. So I think we're going to go ahead and wrap up. I want to thank Adam Parko and Sean O'Mara from Mirantis for joining us, and our special guest Alex Williams from the News Stack. It was wonderful having you here, and of course, everyone who is in the chat. We definitely want to thank you guys. We know that you are busy, and we appreciate you joining us here. And
Totally.
we hope that you will join us for Cloud Native Coffee in 3 or 4 weeks, 4 or 5 weeks, whatever the date works out to be. And join us next week here for another event where we'll talk about the news, and we'll talk about something else, and we don't know what that is yet, but we'll get there. So let us know what you want to see, and we'll see what we can work in it. Thank you all so much. Been a very good conversation, and we'll see you next time.
Thanks all.
Thanks, Nick. Thanks, Adam. Thanks,
for
Sean.
having me. Have a good day, guys.
Thanks,
Bye-bye.
guys. Bye-bye.